She's a skipper.
I know. What are you gonna do? See, I've been in this class twice today already.
That is true.
I'm making it up for her.
All right. Convert the polar equation to rectangular form and identify the graph. It says you can support your answer by graphing the polar equation, but we're not going to do that part for these ones. So, we'll just start with 36. That's fine. So we have r is equal to -2 cosecant of theta. So with these, we need to try to convert this into something that we know rectangular. So I'm going to try to get rid of the trig function on the right side. So I'm going to move it over to the left by dividing. So I'm going to end up with r divided by cosecant of theta is equal to -2. Now, what's another way I can write 1 over the cosecant of theta? Sine of theta. So r sine theta equals -2. Now the question is, what is r sine theta equal to? Y. So I can replace that with y is equal to -2. And so that is my rectangular equation. Okay, so I've gone from polar to rectangular. And what type of a line is this?
Horizontal.
It's a horizontal line.
I think of that when your mom would say, like, flip it, how it's like y is h and then u x.
I know. I always have to, like, think about it. Well, because, like, I know, like, what horizontal and vertical are, but then I have to think about it when I'm, like, looking at it, because then I'm like, wait, is that a vertical line or is that a horizontal line? Okay, hold on. This goes this way. I have to, like, mentally graph the point and see what it is.
So, like, just to be 100% sure about this, so if it's x equals, then it's a vertical line, and it's like the opposite of what the axis would be. Like the x-axis is horizontal.
Right,
But
but
if
the
it's
line
x
on it
equals
is
vertical.
vertical. Yes. Yeah, and that's my problem, because I'm like, wait, but it needs to go this way. So I have to, like, that's why I'm like, I have to, like, mentally graph it and think about it. I'm like, I can draw it for you, but saying the name of it, like, always gets me. Like, I don't know if it'll ever not.
Also, when I'm plotting a point sometimes, like, I just forget, do I go this way and then up, or do I go up and then right, and then like...
I know, right?
Well,
So
I
I was
guess
like,
if it gets you to the same place, it doesn't really matter.
True. Okay, that's all you have to do for that one.
Oh, that's nice. I like that one.
Yeah.
Are we gonna have lots of these on the exam?
On the exam, I mean, the College Board wrote your exam, so I couldn't tell you.
Oh.
I'll call them and ask them. I'll let you know.
38, r equals -4 cosine theta. Well, and it's hard because I look in, like, the prep book, and, like, obviously, again, this is the first year for this class. So, like, I look in the prep book and I think, like, oh, like, maybe this is going to be in there. And then I look and I'm like, they don't even have this stuff in there. But I'm like, they say that we need to do polar stuff. So I'm going to cover everything that our book has provided to us. And if it's not on there, like, that's fine. But I'd rather you have too much information than not enough.
Yeah.
So, all right. Any idea on how we might want to start this one? So if I do that, okay, and the other one, I knew that that was going to convert to give us sine theta. So if I divide by cosine, I have r over cosine theta. Hello? Yes. Okay.
So, yesterday at tennis practice, like Mrs. Finn
Yeah. Can I come over at the beginning of 4th and look at it, and then we can like talk about it? Because I can take them and trim them at home, like too, to get the white off. So like if need be. So yeah, and if we need to like adjust because of the coloring or something with our printer, like we can try to adjust too. Uh-huh. Yeah, that's what happened to me too when I was doing it. I know. I had to like go shrink the writing at one point because it was too close to the edge when I did it. Okay. Okay, sounds good, and I'll be over at the beginning of 4th. Thanks, bye. Trying to get the invitations finished. Okay, so r divided by cosine theta, is that something that I know that I can convert to like x or y? No. How about potentially if I multiply both sides by r?
Go for it.
So that I get r squared is equal to negative 4r cosine theta. Does that potentially give me something that I know what it is? Because what's r cosine theta?
X.
So this would be negative 4 times x on this side. How can I rewrite r squared? X squared plus y squared. So now I'm in with something that I do know, right? So I am going to move, let me think about this. I'm going to move the negative 4x to the left, so I'm going to add it. So I have x squared plus 4x, leave a space because we're going to need to complete the square, plus y squared equals 0. So do you remember when we did it very briefly, but when we did completing the square, we also completed the square with circles to find equations of a circle. Do you remember that? Okay. Maybe that wasn't this class. Well, if you're going to learn something new today, if not, well, you're learning a lot of new stuff. But
So like, are we completing the circle instead of the square?
well, you're still completing the square, but the y squared piece by itself is fine. But I need to get this in circle form, and having the x squared plus 4x is not in circle form. Okay, do we know the equation for a circle?
R squared equals x squared plus y squared, something like that.
So it's x minus h squared plus y minus k squared equals r squared. So essentially, I'm trying to make this look like this. However, in this case, rk is going to be 0 because I just have y squared over here. Because I don't have any other y terms. Now remember, with completing the square, when I add a box to the left, I have to also add one to the right. So disregard everything else, but what is half of this middle term squared? 4. So I put a 4 here. I also need to put a 4 on this side. Now, what does completing the square allow me to do?
Split it up
Into what?
into the perfect square trinomial.
It's a perfect square trinomial, so in this case, what does that give me?
X plus 2x minus 2.
X plus 2 squared.
X plus 2 squared.
You give me the difference of squares one.
Oh.
So x plus 2 squared plus y squared equals 4. So now this is in circle form. And so notice that this sign here is their negative. So the center for this, because it's going to ask us for this, the center for this general form is HK with a radius of R. So I want to talk about where the center of this is. Okay, this is a circle. So the center for this one would be at the opposite sign, so -2. There's nothing with y, so that's just at 0. With a radius of 2. Okay, because it's the square root of this number. So, same instructions, but a little more complicated than 36, right? Let's do one more of that kind. 40. R secant of theta is equal to 3. Now, I haven't worked this one out yet, so this one might be a little trial and error. Well, I hadn't really worked the other ones out, but I'd thought through them. But this one, haven't really done that yet. So, let's think through what we could maybe do here. Do I know r secant of theta? Like, is that anything specifically? How about if I divide both sides by secant of theta? So I would have 3 divided by secant of theta, which is what? 3 cosine theta. So that looks like that could get me somewhere. So let's start there. Might be wrong, but let's try it. So r equals 3 divided by secant of theta. I'm just writing all this out, so if Riley goes to look, she's not thoroughly confused. R equals 3 cosine theta then from that. Now, this kind of looks like what I had in the last problem, right? So, what do you think I should maybe do with this one at this point, based on what I did in the last one?
You'll have to complete the circle again.
Well, I can't yet.
Multiply both sides by r.
Multiply both sides by r, so r squared equals 3r cosine theta. So then r squared is? X squared plus y
I
squared.
think I'm starting to understand this.
And then 3r cosine theta can be rewritten as what?
Yeah.
3x. And just for reference, if you were dealing with like sine or cosecant, the process would be the same. It would just be for y instead of x, but you would do the exact same thing because all the sine ones seem to be odd and all the cosine ones seem to be even. All right, so now we move this 3x over, and again, I know that I'm going to need to complete the square because that's how we solve circles. Seems ironic.
We use squares to find the circle.
So x squared minus 3x plus box plus y squared equals 0 plus box. So what is half this middle term squared?
2.25. That's my guess.
As a fraction is what?
9/4.
Okay, so I'm going to write it as 3 over 2 squared right here, but over here I am going to write it as 9 over 4 just because when I go to do my perfect square trinomial, it's easier to not have already multiplied it through. When it's like an easy number, like the last one was 4, obviously it doesn't really matter, but when it's a fraction, I usually will just write it like this. I'm going to make my box a little bigger so I can actually see it. All right, so what does this factor into over here?
X plus 3 halves.
Minus.
Oh, x minus 3 halves squared.
Yep, x minus 3 halves squared.
Is it just the opposite of whatever is?
It's this sign.
Oh.
The sign of the middle term is what goes in here.
Okay.
Is equal to 9/4. So that's our equation that we're looking for. So now, where's the center of this one?
3 halves and 0.
Yep. And the radius?
Not 3 halves.
3 halves. That's the square root of that number. Yeah. People, even myself included, tend to forget that the r value over there is r squared when you have the equation of a circle, so you have to like take the square root of it. I'm always like, oh man, I have to go back and fix it.
It makes more sense now.
Well, and I guess maybe it's in college algebra that we do it, but we complete the square for the circle equation, and we have to do it for x and y simultaneously. So when you do that, you have to add 2 boxes to the right side because you're adding a box for x and a box for y. So it just is a lot. But I guess we didn't do that in here, so I'm guessing it's college algebra that did it. Okay, we're going to do one of basically going the opposite way, just so that you see it, but I think that the only thing that you're really going to be doing for AP is going this direction. That's why I'm really only going to show you one of going the opposite way.
So are we gonna have to undo the square?
Well, no, not really.
Oh,
It,
good.
yeah, it's, no. 50. We've got x minus 1 squared plus y plus 4 squared equals 17. So what does this look like?
Circle.
Okay, an equation of a circle. Good answer.
Yeah.
Some people are like, what?
What?
How
So-
would we graph that on the calculator?
In polar form. It's the direction we're headed.
We'll get there.
Basically, you just wouldn't do it on your calculator. You would say, well, the center for this is at 1, -4. So you'd put the center down there. And then out, you would take whatever the square root of 17 is, so 4 point something. So basically go out a little more than 4 on each axis and then just connect the dots. But polar allows us to be a little bit more specific with the thing. But we could expect that when we graph this or the polar equation, it's going to look like a circle. So, we are going, okay, we're not like undoing the completing the square, but we're squaring each of these pieces. So basically we're squaring the perfect square trinomials. So what do we get when we do that? Like, what is x minus 1 squared?
X minus 1, x minus 1.
X squared minus 2x plus 1.
Well, I
don't know
mean,
what
I
she
was
dreaming
still
about.
right.
No,
Right?
you weren't.
Well, I mean, yes, you just needed to go farther than that. All right, how about the y plus 4 squared?
Y squared. It's hard to do in my head.
Y plus 16
What?
What'd you say?
plus 8y plus
Okay.
16. What were you thinking, Virginia?
No, I was just trying to do it in my head.
It's 2 times the first term times the last.
Oh.
You'll get it next time.
So now I'm going to move the numbers, okay, the numbers by themselves without a variable, over. So when I do that, I'm left with x squared. I'm going to reorder this, plus y squared minus 2x plus 8y. You'll see why I'm doing that in a second, is equal to 0. Now that makes sense, right? That is equal to 0. Okay, cool. So then, Now I'm going to substitute polar things that I know. So I know that, and that's why I wrote it this way. So I know that x squared plus y squared is equal to r squared. So I have r squared minus 2 times, how can I rewrite x in polar? R cosine theta. How about y? Plus 8. So plus 8 times r sine theta still equals 0. Now, is there anything I can factor out? Yes, an r. So I'm left with r minus 2 cosine theta plus 8 sine theta. So now this is like when we did like solving, we were solving for the variable, and we had, we set each piece equal to 0. So at this point I have that r is equal to 0, and I have that r minus 2 cosine theta plus 8 sine theta is equal to 0. So then on this one, I'm trying to get r by itself, so I'm going to move everything else over. So this is r is equal to 2 cosine theta minus 8 sine theta. And so this is polar form here. Now, r equals 0 is just a single point on a graph, right? It's just a point at the origin because there's no radius, no x values, nothing, no angles. So that's just a single point. But the other one is a polar form equation, which we could graph on our calculator if we were so inclined, as long as you're in polar form. I'll let Josh do it since he seems excited about it. Should be a circle.
That is not a circle.
Do you have other stuff graph?
No. Oh, parentheses. Gotta love
It looked like a ribbon.
It should be a circle. It should prove what we thought.
Yeah, I forgot to put parentheses around, like complete parentheses around the data.
That
There
would
we go.
be important. Is it a circle now? Okay, great. Or at least close enough.
Well, I guess it is a circle. It's just like,
Smushed.
yeah.
So it's an oval.
But that's just because the y's have less space between them than the x's.
There's a few like word problem type things in here. If it looks like we're gonna need them, we'll come back to it after we do 6.5. But I didn't see evidence that you're gonna need it, so we're not gonna do those for right now. They don't look hard. You basically use law of cosines to do them. So I think that's one of those things that if for some reason that happened to show up, y'all could probably figure it out because it basically gives you a graph that looks like a triangle and you just solve it. So, all right, in addition to the problems that you had the other day, I'm going to add on well, I'm going to say 35, 37, 39. You don't have to do all three of those if you feel like you've got it under control. And then 49, which will be like 50 that we just did.
I literally just wrote 40 instead of 49.
All right, I'm going to give out these little packets, and we're just going to look through a couple things briefly, I think. And then let you work on these problems and finish them up.